大家好, 我是 Eli Ben-Sasson. I am co-founder and president at StarkWare, and I would like to tell you a little bit about a mathematical technology called Starks that we first invented and then productized and then placed inside a layer 2 that we hope you will join us in using, which is StarkNet. So the story of the technology and cryptography that is Stark goes back 30 years to the mid-80s and early 90s. And it is the story of mathematical innovation that unleashed a great power and placed it in the hands of humanity. So a good image to have in mind is, often in movies there's, a young and weak child that meets this very powerful dragon and has control over it through some magical means. Well, here the young and weak child is going to turn out to be Ethereum, which is, as a computational device, somewhat limited. And it will be able to control a vastly greater amount of computation by means of magic, and the magic is math. So Starks are based on 30 years of math. A lot of it was invented and honed and baked inside StarkWare. And at its core, what this math allows you to do is to use cryptography in order to assert integrity. So what does integrity mean? It was beautifully defined by the novelist C.S. Lewis, doing the right thing even when no one is watching. So we have this mathematical technology that allows someone to know that the right thing was done even when no one is watching, and do so without needing to watch each and every step of this other bigger computer. And we are using this magical mathematical technology in order to allow Ethereum to scale to global demand. So there's a beautiful quote from this paper from 30 years ago, from 1992, this amazing mathematical innovation. And here's this beautiful line written then. A single reliable PC can monitor the operation of a herd of supercomputers working with extremely powerful but unreliable software and untested hardware. So we have this ability of a very weak and limited computational device. In their words, it was a PC. This ability of it to assert integrity and know that the right thing was done by some herd of supercomputers with no trust assumptions about that herd of supercomputers. And if it sounds a bit like magic, well, there's a lot of mathematical magic that goes into making this a reality. My own personal story is that I started off something like 20 years ago as a young or younger mathematical researcher interested in the theory of computation. And one of the problems I was looking at was to take that beautiful and powerful magic of proofs and make it slightly more efficient and practical. And it was a lot of hard work by my co-authors, colleagues, and myself over several decades that basically took this theory that started off as being not so efficient and ended up as being something that is completely efficient and can be generated and verified on computers. And once this was the case, we founded StarkWare. And the mission of StarkWare is to use mathematics to assert integrity for the purposes of scaling blockchains. In between, I use different aspects of this technology known as zero knowledge in order to add privacy to blockchains. And I was one of the founders of Zcash. But this talk is not at all about privacy. It is all about scalability using mathematics and Starks. Often I'm asked, how was it to go from mathematician to practitioner, from computer scientist, professor to entrepreneur? And the image I have for that is a little bit like, going from this very theoretical to this very practical was like crossing a desert, because the theoreticians and scientists I talked to practical applications, and the people from the practical side did not understand how the theory might apply to them. So for a pretty long time, my colleagues and I had to be walking this sort of desert till we reached the other side and made something that is practically efficient and workable and usable today. But that's a topic for a different story. So this technology that allows you to have a weak computer assert the integrity of a bigger computer, how is all of that relevant to blockchain? Well, let's remember this quote. A single weak computer can monitor and assert integrity over a vaster computation without needing to re-execute that computation. And this is why it's relevant to blockchains. Ethereum, you can think of it as a computer. It's run in a decentralized way by many, many entities, but it's a computer. And as a computer, it's rather weak. Or I would say there is far greater demand for this computation than Ethereum today can support, which is why gas fees are high and the system is congested. So think of Ethereum as the analog of this PC that is rather weak. Using the technology of Starks, you can use this computer in order to monitor the operation and integrity of a much greater computation that is done off-chain. And you can use the same trust assumptions of Ethereum and the same security levels of Ethereum and sort of enhance all of this computation with the integrity and security of Ethereum by virtue of using the magic that is math. So today, in our world of financial transactions, we are faced with two different ways of doing business. There's the conventional way in which credit cards and payment processors and banks operate. And there, you can abstract it away as someone is running a big computer and everyone needs to trust it. And if you want to know whether the system is operating with integrity, well, you're just going to have to trust that, or trust that the government or some auditors or someone is making sure that things are running with integrity. But it's not an inclusive system. It's very exclusive. You and I cannot decide to become a bank and process transactions. That is the conventional world, but it is also very efficient in terms of the ability to compute and process transactions. Blockchains, like Ethereum on the other side, are extremely inclusive, which is really great. Each and every one of us is invited to use our laptops, connect to the network, and be part of its basis of trust. I hope that some of you are doing this. But in order to allow each and every one of us to take our laptops and connect it to the network and be part of Ethereum's base of trust, you need to limit the amount of computation so that our meager laptops can operate. And that is how you get a system that is very inclusive, which is great, but is very slow as a computation device. And that's unfortunate. So what we would like to do is have a system that is as inclusive and allows each and every one of us to add our computers to this network and check that everything is fine, but still have the scale that is offered by huge computers off-chain. And that's exactly the bridge between these worlds is going to be built by Starks and their math. So what are some alternatives to increasing scale? Well, you can just ask everyone to go and buy a bigger computer, but then some people are going to drop off the network. And by the way, some sidechains, some popular sidechains today have done so. Some sidechains in the past have done so, EOS, Tron, Binance Smart Chain, XDAI. These are examples of things that in the past basically said, look, a few of us are going to run bigger computers. You're welcome to join and buy a big computer and be part of this. But even this has a limit to its scale, and also you start to lose inclusivity. For instance, here's one of the demands of one of the popular blockchains today. You need at least 12 cores and 128 gigabytes of RAM, which my computer does not have. So a different approach is to ask, to go with this thing called fraud proofs, like Arbitrum and Optimism. And there, some computers are going to be much, much bigger, which means I will drop off the network with my laptop. However, there are claimed to be various game theoretic incentives that will allow these other bigger computers to check one on the other. Now, currently this technology is not yet turned on anywhere as envisioned. And one would hope that if it works, indeed its security is as promised. But this is something that is, at least to me, not yet clear and not demonstrated. So you get a system that is slightly faster, but slightly less inclusive, because some of us are going to drop off the network. The approach that we are going for is one that is based on mathematical proofs, validity proofs. And what we're saying is, let anyone who wants run a very big computer and process many, many transactions. However, everything that must be done, everything that is done, must be proved to this layer 1, which is the analog of this PC, of this weak computational device, which is the only thing in which we place our trust. So StarkNet is an embodiment of this principle. When you operate on StarkNet, your security is the security of layer 1 Ethereum. You do not have to have any trust assumptions about the goodwill or of the operation of the StarkNet ecosystem. It is all about Ethereum security. That's what the StarkNet layer 2 gives you. And it gives you through this power of math. A good way to think of a proof is like a grocery receipt or a restaurant receipt. In fact, a restaurant receipt is a very old form of proof. So if you think about a restaurant receipt, it is a string of characters that is used to assert integrity. It is used to convince you, the customer, that you should pay the total sum. And the total sum is the result of some computation. So when you receive this receipt, you can check and verify the integrity of the computation by naively re-executing it. So a grocery receipt and a restaurant receipt are examples of proofs of integrity. However, they're not very sophisticated from a mathematical point of view, and they don't offer you any bigger scale because you need to rerun the computation. Well, Stark proofs are similar. What you get in the end, you can think of it as something like a restaurant receipt, but the length of the receipt and the amount of computation needed in order to check this receipt or this proof is exponentially smaller than the amount of computation that is asserted by it. So using this technology, you can take hundreds of thousands of transactions, process them. You need no trust assumptions about who is running the prover and who is processing the transaction. It could be the Lord of Darkness or Darth Vader or the evil whatever it is that you give to process these transactions. And still, that entity cannot cheat and cannot steal funds because any update to the system must be submitted to layer 1 alongside a proof of integrity. And this is what we do. So any update to the state of the system must be accompanied by a proof, and no one can generate a proof of a falsity. If there is a proof, the right thing was done even when layer 1 was not watching. That is the power of Stark proofs. So this is not just theory. I mean, it used to be theory, but by now, this is working systems. And for instance, if you think about minting of NFTs, if you want to use blocks of Ethereum to mint NFTs, you can fit a couple of hundred of NFTs inside a single block of Ethereum. Well, for over a year now, we have been servicing Immutable X, one of our customers. Immutable X from time to time needs to mint hundreds of thousands and millions of NFTs. Our technology has, time and again, minted inside a single Stark proof the correct execution of 600,000 NFT mints. So, and all of this can fit comfortably inside a single Ethereum proof. So you went from hundreds of transactions per block to hundreds of thousands and millions of transactions per block using this technology. Now, StarkNet is the way that each and every developer and user can have access to this marvelous technology that enhances Ethereum and offers it greater exponentially greater scale. What is StarkNet? It is very much like Ethereum. It is a layer 2. You can write smart contracts to them. You can submit transactions to these smart contracts. It supports general computation and composability, but it offers much lower gas costs per transaction because of the magic of Stark proofs. You can think of StarkNet as something that is very similar to Ethereum. From the user's perspective, you submit transactions, all of these transactions go to a mempool, and then a miner picks a bunch of transactions, processes them, places them in a block. Well, what StarkNet is doing is something very similar. It is operating off-chain, so layer 1 Ethereum, which we all love and trust, does not know of what's going on in StarkNet. There are no trust assumptions there. But what's happening is that users are going to be submitting hundreds of thousands of transactions to a sequencer. The sequencer is going to sequence these transactions one after the other, process them, and then these transactions are going to be sent to a prover. The prover is going to generate a Stark proof for the correct update and correct execution of all of these transactions. The proof is exponentially smaller than the amount of computation and the number of transactions, and this proof must now be submitted to layer 1 Ethereum. There's a verifier smart contract on Ethereum, and this is the gatekeeper, gateway, the keeper of integrity that checks that everything is okay on this layer 2. So remember this image of a child that has that has control over some vast magical creature, a dragon or something like that, via the power, in this case, it's the power of math and Starks. So the verifier, this small child, is the verifier that sits on layer 1 Ethereum, but still it can wield vastly greater computational power that resides on StarkNet, that is a layer 2. StarkNet comes with a new language, which is called Cairo, and I just want to spend a few words explaining why there's a new programming language. So you could ask, why does Ethereum have a new programming language? When Ethereum came around in 2015, there was an abundance of very good programming languages like Python and C. But still, Vitalik and Gavin and others made up a new virtual machine called the EVM and a new programming language that goes with it. Actually, several of them. Solidity is the most famous. Likewise, we are now coming and suggesting users and developers use a new programming language, which is Cairo. And it's for similar reasons. So there's a reason Vitalik and others invented Solidity, because there's a new system of constraints that results from wanting to run a blockchain. And you need a programming language that is catered to those constraints. Likewise, Starks have a lot of algebraic and mathematical constraints. For instance, algebraic operations, modulo P, are very cheap, but cryptographic operations, certain ones like Ketchak and bitwise operations, are very expensive. Some things that are very efficient to do in Ethereum's memory model are very expensive over a layer 2 that uses Starks. So if you want to get the maximal amount of scale from a computation, you want to use the programming language that will unleash this scale. And this programming language for StarkNet is Cairo. You can use it to write, and by now there are hundreds of applications being written, including things for voting, virtual identity, DeFi, and gaming. And I hope you will join the vast and growing network of StarkNet developers and users and embrace this marvelous new technology. 谢谢. Thank you very much.